Hi, today we will be presenting our MAT 183 group video presentation. Firstly, I will begin with introducing our group members. Our group consists of 3 members, that is me, Nurhudadini, Damia, and Fada. The topic of our video presentation is application of differentiation. Firstly, I will explain about what is differentiation. Differentiation is a method used to compute the rate of change of a function f(x) with respect to its input x. This rate of change is known as the derivative of f with respect to x. Differentiation also means tailoring instructions to meet individual needs, whether teachers differentiate content, process, products, or the learning environment to make it easier for students to understand. In calculus, differentiation is one of the 2 important concepts apart from integration. Differentiation is a method of finding the derivative of a function. In mathematics, differentiation can be defined as a derivative of a function with respect to an independent variable, while differentiation in calculus can be applied to measure the function per unit change in the independent variable. Next, I will be explaining about when do we apply differentiation. Some common applications of differentiation are finding the maximum and minimum values of functions. Another application is that it is also helpful in finding the maxima, minima, and the point of inflection of a curve. Maxima and minima are the peaks and valleys of a curve. It can also be used when we want to calculate the highest and lowest point of a curve in a graph or to know its turning point. The derivative function is used to find tangent and normal to a curve. Differentiation is also used to determine the instantaneous rate of change of quantities. Now I will be introducing the main topic of our presentation. As we know, there are many applications of differentiation, but today we will be focusing on applied maximum and minimum problems. The process of finding maximum or minimum values is called optimization, where it is trying to do things like maximize the profit in a company, minimize the cost, or find the least amount of material to make a particular object. These are very important in the world of industry. Practical applications are given in chemistry, physics, economics, meteorology, theme park revenue modeling, and space shuttle engineering, where maximum and minimum help optimize values like temperature, revenue, and pressure resistance. Lastly, I, Nurhudadini, will be explaining about ways to solve maximum and minimum problems. The first step is to find the derivative. And secondly, let the derivative equal to 0 and find the values of the variables. The third step is to do the second derivative test. If the second derivative is more than 0, that means it is equal to the minimum value. But if the second derivative is lesser than 0, that means it is equal to the maximum value. Finally, the fourth step is after you have finished gathering all the information needed, you can start solving the problem.
This is our problem statement. An experimental rocket is launched vertically and reached a height in meter of st equal to 160t minus 16t squared after t seconds. Find the time when the rocket reached the highest position from the ground. Hence, calculate the maximum height. There is 2 objectives. First is to apply the application of differentiation to determine the time when the experimental rocket vertically reached the highest position from the ground. Second is to calculate the maximum height by substituting the values into the height function.
Application of differentiation, finding maximum height using derivatives. We are given the height function of a rocket launched vertically, which is st equal to 160t minus 16t squared, where st represents the height in meters and t represents time in seconds. We need to find the time when the rocket reaches its maximum height and determine the maximum height itself. To solve this problem, firstly, we have to find the time at maximum height. To find when the rocket reaches the highest point, we take the derivative of st to get the velocity function below. At maximum height, velocity is 0, so we solve for t. Solving this equation, we get t equal to 5 seconds, so the rocket reaches its maximum height at t equal to 5 seconds. Next, we substitute t equal to 5 into st to get the maximum height. Evaluating this, we get S5 equal to 400 meters, so the rocket reaches a maximum height of 400 meters. To summarize, we use differentiation to find that the rocket reaches its highest point at t equal to 5 seconds, with a maximum height of 400 meters. This method is useful in real-world applications like physics and engineering to analyze motion.